Next up is Brad Gerber. He's a senior from Bethesda, Maryland. He's studying biology, and he's taking classes in business and politics. He spends a large amount of time outdoors, including camping and backpacking, and he's interested in working in public health and healthcare. Now for our next speaker, please give a warm welcome to Brad Gerber.
All right. Thank you to BCTalks for hosting this. Thanks for coming, everybody. So I'm going to start talking about the brain at Boston College. So first, talking about the brain, going through some primary literature, a little bit scary, buckle down. And then at Boston College, how does this really apply? So my interests, I love the brain. I think the brain is an amazing field to study. I think this is kind of how we all see the brain a little bit. It's kind of like this house to an amazing and unfathomable amount of imagination. But in reality, from a neuroscientific standpoint, it's just like kind of a pink, kind of squishy blob that we call the brain. And it has lots of different mechanisms of action. So understanding the brain from neuroscience has to do with breaking down behaviors and looking at the synapse, looking at the molecules that act at the synapse on these larger brain systems. And so what does that do? It kind of challenges our understanding of consciousness. It challenges the idea that we exist behind the eyes, that we're just kind of like a brain driving a car. We're just kind of driving our bodies. There's this mind-body split that is in part an illusion. And that challenges the way we think we make decisions, and the way we think we act. So our free will is kind of at stake here. So this is the definition of free will that I'm going to use and I'm going to refer back to a lot. It's the idea that individuals consciously choose to carry out certain actions and under the exact same conditions could not have chosen to do otherwise. So it's this conditional dependency that fuels our actions. And I'm going to talk about it in a few ways. First is initiation tests, and then going through disorders, so looking at pathology, which is a great model for how the brain works, going to some scientific progress and what that means for the brain and for free will, and then why we should care. And the first thing I'm going to talk about is something that I guess Freud used a lot when talking about the id, the ego, and superego, which is the ice cube metaphor. So imagine the penguin is behavior that you can see with your eyes. Imagine the top of the ice cube is the conscious brain, and then underwater, the bottom part of the ice cube is the subconscious. But it is all one contiguous ice cube. So look at the person to your left and right. You guys aren't looking. Okay. And imagine that you could try and deduce everything that's going on in their conscious mind from their actions and from their behaviors. Obviously, there's some limitations. You can't quite do that. And something called the introspective illusion makes us think that we can do that with ourselves, that we have access to everything that's going on in our subconscious, where we really don't. We can't fully penetrate. We don't know what's actually happening in our entire minds. Kind of think we're exploring this room of the consciousness, but it's not everything. Not all the doors are open. So the first study that really opened this up and made us think that the consciousness kind of bubbles up from the subconscious was by Libet, and he's the founder of a whole lot of different studies. The first one was in 1983, and this is one of my favorite studies. So what he did is he took subjects and he gave them a button. So he held a button in right hand. He had an EEG hooked up to their brain, so this was measuring neural activity, and then he had them look at a clock. And what he asked them to do is, anytime they felt an urge to do so, they were supposed to press the button. It could be 10-second intervals, it could be 10-minute intervals, whenever they felt like it. Click it, and then note on the clock when they had the urge to click, which is, I guess, pretty similar to the time in which they clicked it. And here's what he found. So your y-axis is going to be your readiness potential, so that's like the brain activity. Your x-axis is time. The peak of that, the very peak of that, is the actual action. That's when he clicked the button. And the second vertical line is the awareness to move, the awareness of the urge. That's your conscious understanding of when you chose to move. And then there's this first line. So what's happening here? This is an increase in activity in the brain before a conscious awareness that you're actually going to press that button. So this is subconscious. All this area underneath that first part of the curve is subconscious. And then you understand that you're going to click it. So I think people were kind of confused about what was going on in that initial time, what was happening there. For a lot of people, this flat out disproves free will. I'm not one of those people. I don't think so. I think there's a lot of subjectivity. So it wasn't until 25 years later that Soon came up with this awesome study that is one of my personal favorites. And what he did is, he had two buttons, all right? So it's the exact same thing. It's an iteration of Libet's work, but it's with two buttons. And he said, not only do you pick any time you choose or you click the buttons, but choose either hand, okay? So they're measuring neural activity, except not just full brain with an EEG, but it's in two different brain regions. The SMA, which is called the supplementary motor area, which you don't have to remember, and the parietal cortex, which you don't have to remember either. But it'll come up a little bit later on. And what he found is basically the same thing. So there was a peak of neural activity at the time they pressed the button. There was also a conscious awareness to urge, which happened a little bit before then, but there was also this kind of bizarre subconscious impulse, and they didn't know what that was. But since it was 25 years later, they had all this kind of advancement in computer science and predictive science. So what they could do is they could deconstruct what was going on in the brain in those two regions beforehand, and they could find that you could predict whether the person would click left or right as many as 3 seconds before, which means that if you were just sitting there, I would know and could write down on a sheet of paper which hand you'd click and when before you were consciously aware that you would do it. This predictive science that I think is really, really illustrative of our free will. So 2 more studies. These are brain stimulation studies. One by Fried in 91 and one by Desmerget in 2008. So kind of a big separation in time again. And so what Fried was doing is he was looking at the supplementary motor cortex, which is the same one, or motor area, which is the same thing that Soon was looking at. And he was stimulating it in patients who had epilepsy. And he found 3 things. The first one is that stimulation produced somatosensory stimulation. So somatosensory, it's like you feel it, you felt numb, tingly, maybe pain. The second one was that stimulation produced a subjective experience of moving without actually moving. So that's called proprioceptive stimulation. And the third was a subjective urge to perform a movement or anticipation that a movement was going to occur. So brain stimulation literally induced an urge to move. This was in 91. So fast forward to Desmerget, and he was looking at the parietal cortex in cancer patients who had tumors in different parts of the brain. And he was causing stimulation there. And this is what the stimulation did. It produced a pure intention, that is a felt desire to move, without any overt movement being produced or any muscle activity, basically. So what did this feel like for the patients? Without prompting by the examiner, all 3 spontaneously used terms such as will, desire, and wanting to, which convey the voluntary character of the movement intention and its attribution to an internal source that is located within itself. So brain stimulation produced a literal conscious urge to do something that could only be explained by them as just wanting to do it. And when he increased that stimulation, people literally moved their limbs or completely jiggled their torsos. It's very crazy. It's not a very good idea. And when you asked them about it, they literally said, I just kind of felt like it. I just felt the need to move, which could be produced via stimulation, which is pretty amazing results. And then looking at pathology. Pathology is a really good model for how the brain works. It's typically used when studying neuroscience. Alien hand syndrome and something called utilization behavior experiences. You could probably assume what alien hand syndrome is. It's basically where your subconscious causes a limb to move and you're not consciously aware of it. You typically are doing things that you would routinely do otherwise, that you do a lot. And then utilization behavior experiences are similar. Imagine like putting a pair of glasses on that you already had on. Like you literally reached down and put them on, but they were already there. Reaching in your back pocket when your wallet wasn't there. And they find that as all these people were studying the SMA, supplementary motor area, they found that damage to the SMA created these effects. It created these pathologies of actually not being consciously aware, but doing things stimulated by the subconscious. So it kind of makes us think, what are our decisions and what are our actions? How much do we really control? And then looking at schizophrenia, this is another really good model. So kind of like Pavlov, where you can like kind of train a dog to salivate via some other processes by ringing a bell. With people who have schizophrenia, you can ring a bell and condition that person to do something by their own volition. So this is not like a subconscious process of salivating. It's actually maybe picking something up and throwing it. So you ring a bell and they'll pick something up and throw it. When you ask them, they'll just say, I kind of felt like it. And they won't know about the connection with the bell. So every time you ring the bell, they'll perform that action. So is that action really up to their own free will, or is it the person who's ringing the bell that's choosing when they throw it? Kind of an interesting question. Now this is the progress of science. So I have had the privilege to take a lot of neuroscience classes at BC. They've been my favorite classes in my bio major. And it's becoming apparent, although I'm not an expert, that we're being able to map the brain better and better. We're understanding brain regions, we're understanding connections, we're understanding neurotransmitters and all this kind of different stimulatory input that's going into the brain. So with that ability to map the brain, we're finding out how to enhance it as well. I think we're all pretty familiar with just kind of how drugs work in the brain and what they do, but we're getting better and better at that. We're getting better at understanding how different drugs are affecting our behaviors. We can change that. And eventually, it's not going to be within our lifetimes. It's probably not going to be within the next 100 years. Maybe it's going to happen when we have an artificial intelligence boom, or once we understand real quantum computing or something. But we're going to be able to recreate the brain, I think, at some point in the future. Or we'll be able to use code and create something that looks like the brain, that acts like the brain, that has a consciousness. Will we have just created something that had free will if we could break every decision down to the level of code, which then creates these actions, this kind of illusion of free will? It's a really good question. I don't think so. I think we will be able to. So where does this apply? We're all students at BC. It's obviously important to think, where does cutting edge science lead us? One of those things is social justice. This is kind of a personal issue. I've seen medicine and illness affect my life and my family a lot. And it's kind of a given and a bit intuitive to think that when someone is sick, when there's a biological mishap, when your cells divide, when your blood clots, when your hair falls out, that's not that person's fault, right? We don't think that's someone's fault. We don't blame them for it. There's no stigma around it. In parts of the world, there is a stigma around disease. Thankfully, that's not here. So again, we're not blaming people for things that happen physiologically. And now we look at mental health. Again, we're starting to understand the brain, understand how physiology affects behavior or is the root of behavior. And we don't blame people who maybe have schizophrenia or maybe bipolar or depressed. We don't blame them for their actions. They're kind of acquitted of these things. This is still kind of in the awareness phase because it's hard to look at someone and take away their free will and say, you do not have free will, your actions are not because of your own conscious will, but because of these physiological attributes. So that's still in its awareness phase, but we're getting better and better at that. And I want you guys to think, where does this apply with like real social justice, with how we practice punishment, with how we treat people? When the social sciences allow us to look at, say, neighborhoods and discern who from that neighborhood is going to go to prison, right? Or say you are more likely to be incarcerated because of the neighborhood you're in, or you are more likely to get a college degree because of the neighborhood you're in. Or when we understand the brain to the point at which we can know all of these environmental factors that go into it, how are we still putting people in either solitary confinement or maybe turning away at the idea of prison rape because they kind of like deserve it? You know, that idea is a little bit archaic because again, people are the subject, are the kind of like the result of their environment. It's all this influence. So how does this really apply, right? We're students at BC. We're supposed to go set the world aflame. So we need to understand not only why it's so hard for us to admit that there's no free will, but how it applies and how it kind of like forces us to act in some way. And it's not sad. So I think a lot of people think when there's no free will, there's this inherent lawlessness. You can do anything. I think Brother Kasimov said, Dostoevsky, that's who said it. When God is dead, anything is allowed, which is this idea that like if it's all free will, if it's all predetermined, I can do whatever I want. It doesn't really matter what happened anyways. Whereas when there is free will and when there's full free will and everyone is fully responsible for their actions, we practice retribution. So we blame people. So imagine, like turn to your left and right again. And if someone was to punch you or slap you in the face, how would you feel? You would probably feel really angry. When in reality, if there's no free will, maybe you could just blame yourself and say, okay, I trusted this person not to punch me. Or I didn't know what was going on in his life. It's a lack of knowledge. So again, it's hard to admit to either one. This is one more piece of neurobio I want to talk about. If you are like versed with neurobio, it's a rudimentary description of it, but it's called the limbic system. And it's in the amygdala. So the amygdala is a part of the limbic system that's in gold. And this is our emotion processing center. It's mostly with aggression, with fear, with anger, things like that. The sensory information goes in through the thalamus to the limbic system where it's then processed. It then goes to the hippocampus, which is a memory formation structure, and gets stored as memories. So what's happening is all of our memories, and thus our perception of the world, is being imprinted by our emotional understanding of those, by fear, by aggression, by things like jealousy even. It's like how we understand the world is affected by our emotions. And what those in turn do is it kind of puts us at the center. So it creates what some people would call the illusion of the self, but it makes it seem as if we exist relative to everything that's happening, as if everything is simply affecting us through emotions. I feel angry about that, when in reality, things are just kind of happening. And there's another model I want to point to. So this is called the VTA in the nucleus accumbens. It's part of what people call the dopaminergic reward pathway. If you take opiates, if you take cocaine, if you take alcohol, it stimulates that pathway, and then when you go off those drugs, you get withdrawal. So that's how addiction typically works. And we consider alcohol and addiction to be a disease, right? The disease of alcoholism. And that makes a lot of sense because it is physiological, and these people, when they go and seek out drugs or when they do bad things to get drugs, they're affected by their addiction. Similarly, you can see that with the limbic system. If someone has an underactive amygdala, they're more likely to revert to anger and violence. If someone has, say, like a deformed amygdala linked with their prefrontal cortex, which is how you make decisions, then you do the exact same thing. And what they found is that this is far more prevalent in prison populations. So people who are getting sent to prison are people who lack the amygdala and the limbic structure to really understand the world in an emotional way. And it's kind of funny, this is actually finding its way into the courtroom. People are now in high-profile cases taking brain scans of prisoners or of people convicted of crimes and looking at those brain scans and basically saying, this person really can't be attributed with having done this because their brain is just deformed. It's a disease, right? So our actions, I think, can really be based down to our physiology. And how does this apply with the Jesuit education? These are the three things I chose out to be what I think are the most important parts of a Jesuit education: quest for knowledge, service and the responsibility of service, and then reflection. So the quest for knowledge, I think, is pretty inherent. It's just understanding the world around you and how it affects the human condition, understanding how our environment and our context. If you look back at that definition of free will, it's that it's contextually dependent. If there were the same context, we would not be able to make any different decisions. We're dependent on it. So in some way, I think we're obligated to look and understand how that affects us so that we can understand how we act and what the basis of all that is. And then there's service. So for thousands of years, we've kind of relied on this slightly archaic view of what free will is. And I think it's done a pretty good job of disenfranchising a whole lot of different groups of people. If you look at, and this is just one example, there are a lot of examples. If you get maybe homosexuals and people in the homosexual community, they've been disenfranchised because it was always assumed that they were making these, I guess, what were morally wrong decisions on their own volition. It was their choice. When in reality, we're looking and finding that this is actually kind of a physiological thing. And there are obviously some other ethical positions as to why that's not wrong. And then I think it also applies to the present. So understanding the present, understanding how we're judging falsely certain people for their actions, and how we can't really give everyone full free will because the environment is such a huge factor in our own personal formation and then the formation of the decisions that we make. And then this last part is reflection. I think this is kind of the most important part. It is the heart of a Jesuit education and of a place like Boston College. And that's understanding our emotions. It's understanding that limbic pathway. It's understanding the filter of emotion that we see the world through, such that we don't have to see ourselves in some emotional relativity. We don't have to see things as being against us or good for us, but just as being without us at the center of it all. And then understanding what's influenced us in a way. So that same quest for knowledge, understanding how the environment affects the consciousness and the subconscious, we have to do that inflexibly. We have to understand that ourselves through introspection. So a lot of people think that determinism is a bit of a depressing topic. They think it basically means that we're all just automatons, that we're like biological robots, that we don't have really any decision over what we do, and they dwell on those facts. They dwell on the facts that we're kind of brainwashed by the environment around us. But personally, I think you gain something from that. I think you gain a connectedness with the rest of the world. This is a picture I took while I was abroad, while I was camping out. You can see it very well. It's in New Zealand. And I found this stack of rocks, which is just something that hikers do to show you where the trail is. And I kind of thought that in some way we're like a stack of rocks, and that we're far more complex than a lot of the things around us. If you look at our physiology, if you look at our brains, but we're made of the exact same thing, like the rocks were with the mountains. We come from the same thing. We're under the same rules, the same physical limitations, and we're kind of destined to the exact same fate as the rest of the world. Those rocks kind of perfectly illustrated how humans are in some way. And for me, this was a bit of a spiritual experience. It depends on what your kind of your understanding of what spirituality really is. But I thought it was really perfectly summed up by a quote that I read a few years ago by Albert Einstein in one of his letters. Someone asked him what his views on religion and theology were, and he said that he didn't believe, he was a total atheist, but he believed in these intense cosmic feelings, these really deep feelings of connectedness with everything around him that I think can really only be derived from something like this. An intense understanding of neuroscience and of how the world affects us because we are simply a part of it. And that stuck with me, and I think as I've gone through my own, I think everyone kind of battles with their own journey of spirituality and understanding what that means. I think that's where mine takes its place and where it takes its direction from. And that's the end of my BCTalks. So thank you for listening.